Welcome at this webinar, Can We Save the Potato? I can't see everybody who is here, so there are no screens for me, but I would like actually to know who is watching. So I was thinking maybe everybody could put his name, his occupation, and his favorite potato dish in the chat, so we can get to know each other a little bit. So, mashed potatoes is here the first one. Two mashed potatoes. I like it. What's your favorite dish, Anja?
I put it in the
Oh
chat,
yeah.
but it's potato pancakes.
So I think we have a nice program going on today. We are addressing one of the most pressing issues in farming, I think, in potato farming definitely, and that's late blight. It was quite problematic historically. I think Johan will also talk a little bit about that, but still it is one of the most common enemies of farmers. And today we will explore a little bit on how new breeding technique can maybe help farmers in addressing the issues around potato farming. It might be good for you to know that the program is first we have some presentation, we will have a panel discussion, and after that we have some questions from the audience. And the idea is that you put your questions in the live chat, and so I will pick them up and ask them afterwards. So you don't have to ask them yourself. I will do it, and I will hopefully have many questions in the chat, and I will pick the best ones and the most interesting ones. I think we have a very diverse array of panel today of people here because we have a farmer, we have a researcher, and we have a communication experts from different sides of the world. And I'd like to kick it off just first with a farmer, the people who really do the hard work, who really breed, at least grow the potatoes. Can I give the floor to Johan Barendrecht? I know he doesn't really like it, but I can call him an expert or a top farmer in the Netherlands. Johan, tell me a little bit who you are and what's the issue with potato farming in the Netherlands?
Yeah, thanks, Ede. Yeah. To introduce myself, I'm a potato farmer in the Netherlands, as Hidde said. I'm about half an hour north of Amsterdam in Polder, so reclaimed land from the sea about 300 years ago. I got a arable farm and I grow potatoes, wheat, sugar beets, and celeriac, and we're harvesting that right now. So I just came from the field, so I'm maybe a bit underdressed for a presentation, but I was still in the clay and in the mud 10 minutes ago. So, but today we talk about potatoes and late blight. And I might also introduce myself as I'm also a member of Agrico. That's a cooperation of about 800 farmers. And their main purpose is to trade seed potatoes. So that's a co-op of about 800 farmers breeding potatoes, so new varieties. The Dutch farmers grow the seed potatoes, and then Agrico is exporting them all over the world, about 90 countries. And we breed several new varieties every year. And in the certified seed potato business, Agrico is has a global leading position, and it happens to be that I'm also the chairman of this cooperation. So I have a bit more inside info probably than other farmers. Today, Hidde asked me to address the issues with late blight. Late blight is a fungus that is a serious problem in growing potatoes, and it goes a long way back. As people may know, in 1840, I looked it up yesterday, there was a major late blight crisis in Ireland, and that caused very big crop failures, and 25% of the population died or migrated to the United States. So the problem is already very old, but we're still battling it. And we try to battle it by breed better varieties that have better resistance. But the mutation of the virus also is going pretty quick. So it's kind of a race against keeping up with the new mutations, and also find better varieties, and then the mutations of the fungus mutate again. So that's a problem. In the daily practice as a farmer, blight has become a bigger problem the last few years in Western Europe, I would say. There has been a few mutations in the fungus, and the ban of chemicals for environmental reasons is going pretty fast. So the toolbox for a farmer to fight the Phytophthora by ag chemicals is getting tougher. And I also think that last few years we had pretty wet summers, so lots of humidity, and yeah, a virus or a fungus develops quicker if there's more humidity. So yeah, I think until 5-6 years ago we sprayed potatoes like probably every 7 or 8 days against blight, and last 2 years I'm back sometimes to 3 or 4 days, and that is something I'm particularly unhappy with for several reasons. First of all, cost. I'm sponsoring the big ag companies quite a bit by spraying so much chemicals, but if I don't, my crops will not survive. And yeah, we have some experiment in the Netherlands every year, and that's what we call organic potato farming. There they do not use ag chemicals, and last year you saw that yeah, basically the organic crops yeah, only probably have a yield of maybe 15-20%, I would guess. Just some fields didn't make it at all. Before the tubers start to set, the leaves were already gone, so there's no production at all. And other fields of organic potatoes, they yeah, they only had a very low yield, because yeah, the vines were gone before production really developed. I have to spray a lot, and I also yeah, we're in a very dense populated area, so from a public matters, or how do you say that, point of view, it's also not very popular to spray your fields every few days when there's like civilians living close to it. So yeah, that's an issue, and I think breeding technology could really help us fighting this battle, and create better varieties, and by that reduce the inputs of ag chemicals. Because I think in Western Europe, about between 30 and 40% of all the agricultural chemicals used are used for late blight applications in potatoes. So if we can make better varieties and fight late blight with breeding technology instead of chemicals, we could really do a really good job in reducing ag chemicals. So yeah, there's a lot of pressure from the industry to create better varieties. At Agrico, we're also yeah, pushing really hard on making better varieties. We got several varieties that have 1 gen resistant now, and we presented another one last week that has 2 gen resistance. And yeah, this year we could see that the varieties with 2 gen resistant just kept up. They stayed. The vines got not hurt, and they had a reasonable yield in organic as well. So yeah, that gives me a lot of confidence to fight blight in a more sustainable way. And in our breeding station, we have varieties that have 3 or 4 gens as well, but they're still in the research phase. But yeah, the problem with breeding potatoes is it takes about 20 years to come from a single crossing to a commercial variety. And I think with better breeding technology, we could reduce that scheme from probably 20 years to 10 years. And yeah, we could get to the point earlier where we can ban or reduce ag chemicals very strongly. And I think that's a purpose us farmers are really looking for, and also is a great commercial opportunity for Agrico as a breeding company.
Yeah. Thanks, Johan. Just some questions before I go to the next speaker. So there are resistant varieties, but it's a constant battle. Like,
Yeah, resistance is not the right word. We call it robust. Yeah, because they're not resistant, but and then you have different types of late blight, and yeah, then it depends on what type of late blight you have in the area or they keep up. But yeah, the more genes you have that are resistant, or yeah, you're the researcher, how do you call that?
yeah. And you're saying like it takes a long time for potatoes to breed. It's also because you don't breed with, they don't have any seeds, or is it they're different than other crops or not?
Yeah, because it's vegetative. Or how do you?
Vegetative.
Yeah, vegetative.
Crop. Yeah.
Yeah.
Yeah, so they're they're cloning themselves, and so so that makes breeding harder than a tomato.
Yeah, exactly. And at Agrico, we start with about 300,000 new seedlings every year, and we usually end up with 2 or 3 that will make it. So it's really a process of cutting down and throwing out, and and I think artificial intelligence and new breeding technologies could make a lot of progress in that work to speed up the process and to be earlier in reduce of ag chemicals.
And like maybe the last question before I go to the next speaker, you're now like in the midst of harvesting celeriac. To compare, how often do you spray a crop like this, if you compare it to potato?
Probably over the year, once in 3 weeks.
Oh yeah, exactly.
And
Yeah.
then
So
you
that's a
start
big
with
difference.
then you start with weed control, and you just do a few fungicides applications. So that is a big difference.
Yeah. So that's a nice bridge to the next speaker, I think, because so potato farming is really like full of hardship. So especially like this year, it was really wet, so we have like very early Phytophthora, so that makes it even harder. But there might be a solution, and our next speaker is another leader in the agricultural industry. Let's say it like this, but this time in research. Anja Lukasiewicz, if I pronounce it right, holds not 1 but 2 bachelors. You have 2 bachelors in European studies and in biology. She did a PhD in potato breeding and now combines her 2 studies at Wageningen University, where she specialized in policies surrounding MBTs. And she will tell a little bit about the new solutions for farmers like Johan. The floor is yours, Anja.
Yeah. Shall I share my screen?
Yeah, I think so, yeah.
Yeah, perfect. Yeah, so Hidde already introduced myself a little bit already. But I'm Anja Lukasiewicz. I'm from the Netherlands, but my parents are Polish, so that's why I have a difficult surname. But most of the potato dishes I know are also Eastern European. So a little bit about myself. I did my PhD at the University of Ghent, but I studied at the University of Amsterdam, molecular plant biology. And during my PhD, I mostly work on gene editing, so using CRISPR-Cas to knock out susceptibility genes. So Johan already was talking about resistance or resistant genes in potato cultivars, and another possibility is to knock out genes that already are in potato that the pathogen uses to infect its host. And the gene editing worked actually quite well, but the regeneration from protoplasts was pretty difficult, I have to say. And at the moment, I've been working at Wageningen Research for over a year now, mostly on policy and regulation of new genomic techniques. And this is because I also did an internship at the European Commission at the end of my PhD, which is a 5-month internship, and there I was mostly also working on a proposal for gene editing in the European Union. So I'm basically combining my both backgrounds, European studies and biology at the moment. So a little bit on definitions. I think most of you already know this. When we're talking about GMOs, so genetically modified organisms, mostly we use a GM, which stands for the older techniques. So using classical insertion using Agrobacterium, and then you can have a transgenic insertion using genes from non-crossable species or a cisgenic insertion from crossable species. So if you compare this with potato, you can use genes from old potato cultivars and insert them immediately into commercial varieties. And then when we talk about NGTs, so the new genomic techniques, also called gene edited, so GE, we're talking about all these new nucleases that have been discovered in the last 20 years. So of course, the CRISPR-Cas9 nucleases, which is the most famous one, the other Cas enzymes, but also the talons, the zinc fingers. And ODM is also a part of it, although it's not a nuclease, so the oligo-directed mutagenesis. And then when we talk about NGTs, we talk both about targeted mutations, but also targeted insertions, so targeted insertions of cis genes. A little bit, just briefly on the proposal, because I think we'll also be talking a little bit about that. When you talk about regulation in the European Union, the most important GMO regulation is the GMO Directive from 2001, and also regulations that came afterwards. And these specify the coexistence, the labeling, monitoring of GMOs in the European Union. So it's a directive, so each country can actually decide how it proposes these regulations, but there's a common regulation in the European Union. And then also each country has an opt-out possibility. So you can decide nationally if you want to cultivate GMOs or not. And most of the countries in the European Union don't cultivate GMOs, but there's quite a lot of imports still. When you talk about the proposal for NGT regulation, so you have this directive that's from 2001. And the question actually arose if NGTs should be included in this GMO directive. And this was started by a small farmers organization in France. And
Maria, sorry, Anja, sorry. Can you put your slides in presentation mode? Because the slides do not change, I see people say in the chat.
Okay.
So if you can present it like, it's still on the first. Yeah.
Oh, that's weird because I do see them changing, so I'm not sure.
Oh really? Oh, that's weird. Okay, now I see them change. So continue, please. Sorry.
Okay, so do the people in the audience also see them changing or not? Hello? Mm-hmm. Okay, yeah, I'm not sure if I understand that, but yeah. Yeah. Okay. Yeah, page 7. Yeah, I'm now on page 7, so maybe I should just present it like that. Is that okay? Yeah. Is that do you see it now or not? It's a new system, so I'm not.
Yeah, I think this works. If you just like, but you have to like manually do it on the.
Okay, yeah, that's fine. Perfect. So in 2018, that's where the whole proposal actually started, is when the European court decided that the NGTs do fall indeed under the GMO directive. And this started a whole discussion. So the then presidency, so that was Portugal, asked the European Commission to start a study to see if this was actually applicable to NGTs or not. And this study was published in 2021, and the main conclusion was that indeed the GMO directive was not fit for purpose for NGTs. And last year in July, the European Commission came with a proposal where NGTs would be categorized into two groups, so 1 and 2, and then will be excluded from some of the directives in the GMO regulation. Yeah. So once the European Commission comes with a proposal, both the European Parliament and the Council of the European Union have to vote on it, and the European Parliament already voted in favor. And both of these institutions can then also propose amendments. And the European Parliament also did that, but the European or the Council didn't come to a decision yet. And since the new elections and also the new presidency of Hungary, there hasn't been a lot of movement for this proposal. And if you look at how the regulation now looks, if you look at the GMO directive and the different parts of it, so for example, the risk assessment of GMOs, the detection method, the labeling, and so on, you have the conventional breeding methods that fall outside of it and also are allowed for organic farming. And they have some of the exempted methods that still are part of the GMO directive, but don't have to abide to all these necessary risk assessments, for example. And in some cases, they are also allowed for organic farming. So not all of the organic farming groups want to use these methods, but in the European regulation, they are allowed. And then you have the old GMOs that do have to abide by this directive. And the proposal is that there will be two other categories, and then category 1 would be the most interesting one because there will be more things exempted for this category, but none of the NGT crops would be allowed for organic. If you look briefly into how GMOs are, where they are grown and how many are important, you can see that there are only a couple of larger crops that are GMO crops that are grown in certain parts of the world. A lot of diversity is seen in Northern America, but there are also a lot of crops grown, especially maize, cotton, soybean in South America and also in Asia. But how does it look for gene-edited regulations worldwide? So I already talked a little bit about the situation in the European Union, but there are quite a lot of movement in terms of regulation in the world. So this is a map that I composed based on the current stance. So the countries in green have mostly deregulated gene editing. So they don't see gene editing as the same as the classical GM crops. And there's a little bit of difference. So some countries have a case-by-case method. So they decide for each new application if it's gene edited or not. And some countries, such as the USA, in some cases also Japan, it's automatically deregulated. And the countries in yellow, they're mostly proposals still or discussions. So just a few examples. So Canada, it's mostly deregulated, but it's case by case and trade based. So they look if the trade could have also been made by conventional methods. Mostly Russia is sometimes also put in yellow, meaning that there's a proposal or discussion, but at the moment, as far as I can see, there's only research allowed in gene editing in crops. And also for China, they have deregulated 1 or 2 events, but there's no clear regulation at the moment. And then the countries with the star are the only countries that actually have gene-edited crops. So that's Canada, America, so the USA and Japan that are available on the market at the moment. So when you look at gene editing in potatoes, so Johan already talked a little bit about Phytophthora. And there's a lot of research also in the Netherlands going on this, also a lot in Wageningen, and that's mostly based on the insertion of resistant genes, so cisgenesis. But there's another field, so the knockout or the silencing of susceptibility genes that I already mentioned at the beginning of my presentation. But it's important to combine this, but also look at the different pathogens that are in the field. So if you insert only one resistant genes, it won't be enough to really get a durable resistant potato cultivar. So you have to insert multiple resistant genes and also monitor how the pathogen is evolving in the field. But you can also think of applications such as combining resistant genes together with the knockout of susceptibility genes. And this Phytophthora-resistant potato with inserted resistant genes has actually been part of a report for JRC, so the Joint Research Center, where they looked at how these gene-edited disease-resistant crops would help in, for example, lowering the use of pesticides. There's also a lot of other research going on. I'm not going to mention all of it, but for example, we talked about how potato is vegetatively propagated, and there's a company in the Netherlands, Solinta, that is trying to develop a hybrid seed. So instead of using seed potatoes, using the seed of potatoes. And when we look at what's happening worldwide, there's one event, so the non-browning potatoes from Simplot, where they used RNA silencing to get potatoes that don't turn brown. That one is on the market at the moment in the US, and that has been approved as a GM potato. With the new regulation, it would fall on the gene edited. And there's actually quite a lot in the pipeline, but I have to say that it's pretty promising, but it's not on a commercial market yet, so it still has to prove itself. So there's a potato with an altered starch production, so they don't have to use as many chemicals. And then also the disease-resistant potatoes, not only against Phytophthora, but also against other diseases. And they're also looking at, for example, drought resistance and other traits. But like I already said, it still remains to be seen if this product, because in the end, the consumer also has to be willing to buy it. And that's my last slide. I hope you could still follow it a little bit. I'll stop sharing. Yeah.
Thank you, Anja. That was interesting. Again, please, people, if you have any questions, put them in the chat already, because we will combine them at the end. And it's still a little bit silent in the chat. And I know you're not that shy, so please come across with all the questions. Anja, I got maybe a little bit of a bridging question to the next speaker. Do you think these new breeding techniques, do they hold a bigger potential for small-scale farmers than traditional genetic modification? Because I have the feeling that a lot of the genetic modification traits are focused on really big, large-scale crops, at least, and feed maybe even. Do those entities hold a bigger potential?
I think they can hold a bit of potential, but then it's important to also adapt the correct relations. So I think the problem with the original, the older GMOs was that once these really strict regulations were in place, at least in the European Union, it was only interesting for larger companies to apply it for larger crops. And this is something that they really want to do differently for NGTs. So they really want to make it available for also small companies. But indeed, it is a question that often comes up, like how do we make sure that this technology is also available for smaller farmers?
Thank you. So over to the next question, and this guest holds a very special place in my heart, because I think 8 years ago I made my first movie, and it was on genetic modification, and it was on genetically modified eggplants. And I was back then a very amateuristic filmmaker. I went to Bangladesh very ill prepared, but there was one guy who actually made the success of this film well fed, and he's called Arif Hossain, and so I'm very happy to work with him again. He's a science communicator, I would say. He worked at Cornell, and he leads the Bangladesh chapter of We Planet, and has held various positions in the organization trying to modernize Bengali agriculture. And I actually saw, Arif, that the regulations in Bangladesh, I was looking at it on the map of Anja, they were green. So it seems that they are deregulated, but I also remember that you have a little bit of a different story. So the floor is yours,
Right.
Arif.
Thank you, Hedi. I mean, it's been a privilege to see you again and with two the esteemed speaker and an expert we have here today. If you allow me, I can probably jump into the presentation and then we can talk a little bit.
Sure.
I'm trying to see how it works. Uh, oh, do you see my slide? Hedi?
Yeah.
And is it changing?
Yes.
Okay, can we save the potatoes? I think we have saved potatoes for maybe 8,000 years now, the time it took to get domesticated. And I'm going to talk about potato, but would like to touch a little bit about the agriculture in Bangladesh, how rural household and the GDP depends on smallholder farming and agriculture in the country. And apart from that, as they're talking about next generation technology or biotechnology, genome editing, GMO, these are the four crop we have currently in Bangladesh. BT eggplant, which was approved back in 2013. And he just mentioned that he visited Dhaka in Bangladesh. We traveled around the field, captured interview and saw the picture and the story of BT eggplant in his movie Well Fed. Then the approval of golden rice is awaiting since 2017. It's been a long time, almost 7 years, more than 7 years now. It's enriched with beta carotene. It's been approved in Philippines. Then we have court case and like the issues with anti-GM activists and Greenpeace. They blocked golden rice in Philippines and also in Bangladesh. Then the trial of potato. I'm going to talk a little more about it in my later slides. And recently, last year, we just got approved BT cotton and right now, 134 farmers we have had trial in the field, and we are waiting to get the outcome and result of the trial field. What about potato? Potato is the most important crop after rice and wheat in Bangladesh, and we are the 10th, within 10th, like top producing country. On an average, we produce more than 10 to 15 million metric tons of potato a year, and it's most important crop for smallholder farmer, particularly from the northern region of the country in Bangladesh. As I mentioned, that potatoes are mostly consumed in Bangladesh. These are table potatoes, we call them. Diamond, Cardinal, Asterix, Granola, these are few popular variety. Those are grown by the farmer for their income generation and for the consumption of the people. And what are the challenges of potato? We have already talked about challenge, lead blight. Then we have issues around limited storage facility for the smallholder farmer. And the market is also not very much stable. I mean, the supply chain gets disrupted due to blight infestation, due to climatic event like flood. So the productions are not stable in last few years, and we have seen that it impacted the local market significantly. For blight in Bangladesh, I mean, farmers lose potato and the harvest significantly. And it's quite unpredictable. Some year you see no blight, and some year you see like fields are completely destroyed due to, climatic condition, fog and cold. And on an average, we uh, import or, buy more than 500 tons of fungicide costing 10 to 12 million US dollar. And the total production cost is huge for potato in Bangladesh, and 25 to 28% of the total production of potato actually farmers, particularly smallholder farmers, spend for fungicide spray. And it's impacting the field, their health, their economy, and also the consumers and the environment. These are few field. I have been fortunate to move around, and my colleagues they traveled in the country, and in different locations we have seen how blight actually see this whole field is completely destroyed. And when you don't have enough vegetation and you have lead blight, then you don't have proper good tuber. And this was like the market crisis last year, even this year. And right now, this is like the high time for potato seed transplantation, and the farmers are struggling to get potato seed, and they are paying twice the price of what they have been doing last year and the previous year, because blight in the last season, blight actually affected the potato production, and we had some crisis. The dollar in local market was not very available for the farmer. So with all these together, both the consumers and farmers right now are struggling to get enough potato on their plate and in the field. What is the solution? So farmers were struggling, and then scientists have been trying to identify the traits, and they have been able to identify 3 wild species who are resistant to lead blight, and they genetically modified the targeted potato variety. For our case, it was the diamond, because this is like the mostly grown potato variety in Bangladesh. So they inserted three resistant gene to the diamond, and for next generation farming or next generation crop, we are trying to introduce
I also think that Arif might have some issues with his Wi-Fi. Let's see if he comes back. It worked quite well. Let's see if I can. I think Arif is trying to re-log in. Maybe Johan, if you do you recognize any of the varieties they use? Is it something you?
Yeah, actually, diamond. I used to grow diamond, and I also exported it to Bangladesh.
Yeah, I thought so.
And,
yeah, nice.
And diamond is also used to be an agricole variety, but it's,
nice.
It's a free variety now.
And I saw that they were actually breeding in 3 resistant genes. That's quite a lot.
Yeah, but we were not to the States, or they were any successful yet, was it?
Yeah. Let's see if so it might well be that they're growing the seed potatoes from your farm.
Yeah.
Nice.
Yeah.
Let's see if it's Arif. Are you coming back? You also worked, Johan, in I think it's Syria, or not?
Yeah, correct.
Yeah. So and that's a whole different climate, but still, Phytophthora has a problem there.
I think a bit less because it's a very dry climate,
Yeah.
and they grow potatoes under irrigation. So then the period in time that the vines are wet is quite short, and then your infection risk is a lot less.
Yeah. Trying to fill the space. Anja, like maybe I could also ask you if you look at the research in Bangladesh where they're trying to integrate the 3 genes. For me, it seems like, because I always like if I speak to farmers, they're talking about like single or double resistance. This seems quite a feat. Of course, it's not on the market yet, but so you're on mute. So you're still on mute.
Yeah, sorry. So 3 genes. Yeah, no, that's already. It also already has been done at Wageningen itself. So
Okay.
I think 3 genes is it's actually what you need. I think that's almost minimal, looking at how fast the pathogen is evolving in the conditions. It's ambitious, but it's definitely possible. I think. Yeah.
Most of it is still in the research stage. I think commercial. I think there's not 3 G available yet. but
Yeah.
it won't be long.
Yes.
Arif is coming back. I was planning to get some questions from the. But you're back, Arif.
Yeah, but I'm not sure when I got dropped because I've been like talking and talking. Should I share my slide again if
Yeah,
it's not
so I
finished?
think we remember. If you pass the slide, I think we will remember where you were
Okay,
talking the voice.
sure. Let me share the slide. Sorry for the inconvenience. This is like the challenge we have for developing countries.
Yeah, exactly.
So you saw these, right? The
Yeah, I
potato.
saw this one and the next one also. Yeah, further down. I think you were at slide 11. So we were
This
actually
one.
talking about the tree
Okay.
resistance. Yeah, I think we were
Okay.
here.
So these are like the three resistant gene we got from the wild potato varieties. Then this is I'll try to be very quick.
Yeah.
And this is the difference between the lead blight and the GM variety. This is the field I was going to share, that this small little island of green island you see,
Yeah.
these are resistant to 3R gene. And these are like sprayed fungicide sprayed field. So these are like miracle crop to the farmer and to the stakeholder that we have engaged last year. We have been able to engage scientists, communities, farmer, and regulators last year to show them the difference of GMO and genetically engineered crop. And we have recently done a study, and you can see that in 30 years of time, over the period of time, we have significant impact of biotechnology, GMOs. And if the decisions are delayed, that actually impacts the farmers and the consumers too. We did a study, and hopefully in a couple of months we are going to launch this study with um, with the stakeholder and community. So as we Planeteer and other platform that we belong, we are literally trying to advocate for biotech, GMO, and next generation technology, cutting edge technology. And I was going to share a video. Let me know if you can see my screen and the video that I am planning to share.
Yeah, let's definitely see it. I already saw it
Yeah.
before and it was quite
Leaf
impressive.
blight is one of the most devastating diseases in potato. It caused by a fungus-like microorganism known as Phytophthora infestans. Around 20 to 100% yield loss occur by this pathogen worldwide. This potentially devastating disease can infect potato foliage and tubers at any stage of crop development, and within 5 to 6 days spreads to the entire field. Late blight disease affects approximately 18 million hectares of potato crop globally. An estimated annual loss due to late blight alone amounts to approximately $6.7 to $15 billion.
এত নেট বিলাইট এরকম ব্যবহার কোনোবার হয়নি, এইবার প্রথম। এই সিজনে মনে করেন নিম্ন আপনি 15-20 বার ওষুধ দেওয়ালিবি, তার নিচে মনে করেন হবার লাই যে পরিস্থিতি, একদিন 2 দিন পর স্প্রে করলি, কিন্তু আমি ওষুধ দিয়েও কাজ করতে পারিনি। মানে 2 দিনের মধ্যে আলু গোটাল ভিউ সাফ করে ফেলে যাচ্ছে, খালি শুধু গাছের আগা বেঁচে আছে। বিঘা প্রতি আমার 40-45 হাজার টাকা খরচ, আমার না হলে 1.5-2 লাখ টাকা ক্ষতি হয়ে গেল।
এ যাবৎ পর্যন্ত আমি 8 বার স্প্রে করছি। এক গেমারিতে স্প্রে করতে কমসে কম 1000 টাকা লাগে। আমি 3 দিন পর স্প্রে করছি। 3 দিন পর স্প্রে করেও তাও আমি জমি আটকাতে পারিনি। যেরকম ক্ষতি হচ্ছে, এবার ঘাটতিটা আমি পূরণ করতে 2 বছর পারবো কিনা একমাত্র আল্লাহই জানে।
কৃষি অফিসের লোকেরা মনে করেন এসে পরামর্শ দিচ্ছে, চেষ্টা তারাও করছে, আমরাও করছি, কিন্তু আবহাওয়া এত খারাপ ওষুধ দিয়েও কাম হচ্ছে না।
Potato is the third significant staple food in Bangladesh and playing a key role in our food security. But in Bangladesh, annual yield loss for potato late blight is 25 to 57%. Fungicide applications in potato field is 400 to 500 tons each year, which worth Taka 80 to 100 crore. To address this challenge posed by late blight, the scientists developed 3R gene late blight resistant potato. 3 potato late blight resistant genes were discovered and isolated from wild potato varieties. Scientists have transferred these 3 genes into potato varieties like Diamond, a variety widely preferred in Bangladesh. The scientists of Bangladesh Agriculture Research Institute, BARI, are documenting data and preparing all due diligences prior to the commercial release. The data from the ongoing multi-location confined field trials will lead to the selection of the best varieties to be released.
Finish the trial. We hope this 3R gene red blight potato will be very prospect in our potato cultivation, and if we release this potato variety in our country, so farmers can be benefited with these varieties. With the cultivation of the 3R gene red blight potato varieties, farmers do not need to spray fungicide to protect their crop. So this is the very promising technology if we give this technology to our smallholder farmers.
Yeah, so that was my presentation and the video. Thank you.
I can't hear you, Hidde. I don't know if it's... Yeah, no, it's fine.
The mic is off. So
It's
okay,
no,
fine. Good. Thanks. I think we now continue to the panel discussion, but I'd like to start with Arif commenting a little bit on this video, because I'm always also quite shocked how Bengali farmers or small-scale farmers, how they spray without protection.
Well, I mean, like fungicide according to the farmer, because I had the same question to them that don't you feel threatened about it? So they have an indicator, whether it's fungicide or pesticide. If they feel rash on skin and if they feel irritation, then they consider it's harmful. But for fungicide, it's okay. I mean, to them, fungicides are not harmful. I mean, they don't feel any irritation on their skin, so they don't put mask or other thing. But from the government and on record and on pen and paper, it's mandated that you have to wear mask. You have to have your proper gloves and shoes. But remember back in 2016 and 17, when we were out in the field, we have not been able to find anyone with mask and the proper thing. Yeah. So they've been doing it, and we have proper professional sprayer in the country. I mean, most of the time farmers don't spray fungicide or pesticide or herbicide. They hire the professional sprayer from the community, and they've been complaining. Remember, you and me and our friend Kirsten, we made a pile of pesticide, and so these are the thing. And in last 10 years, things have not changed.
No. What do you think about it, Johan, if you see spraying like this?
Yeah, it's a bit different than we do, but it's also a different scale. So yeah.
And so, if it's possible, you can also, of course, react to each other. But another question, Arif, I remember that in 2016, when I was in Bangladesh, you were quite a progressive country. While India was actually holding back on introducing genetically modified crops, you were actually taking them. But how is it now?
So we are still progressing, and we have not progressed much. So progression is a dynamic word, it's a dialectic procedure. So unfortunately, we have not been able to improve the enabling environment for biotech and GMO. It has been politically pressurized, meaning that when you have a supportive system or per se government or the minister, then things go on and move on. And when you don't have a supportive system, and this system is not backed by science, rather it's backed by individuals' preference and whether they like it or not, that is most important for decision making, not the decision or the technical recommendation from scientists.
Yeah. So your current Minister of Agriculture is not much of a fan of?
We don't have a Minister of Agriculture now. It's an advisor for agriculture. They are relying on the suggestion and guideline from the different committees that we have. So we are actually looking forward that, okay, things will move on. And one good thing happened in last December. The Ministry of Agriculture actually approved HDN1 and HDN2. I mean, genetically transgenic crop will no longer require deregulation. So they have like made it flexible. Then the question comes that how many crop actually we have those are transgenic, and what human capital we have built in last 10 years. So I think these are the area we can definitely critically look into.
Cool, thanks. Like, and Johan, like, how do Dutch farmers look at those new breeding techniques? Are they like willing to adopt them if it's possible?
Yeah, I really think so. I mean, I think every farmer wants to reduce chemical inputs, and for environmental reasons, but also for financial reasons. So yeah, I don't see any problems why farmers would not like new breeding technologies if they can grow better and healthier crops.
Yeah, and so you would like argue that for potato this is crucial.
Yeah, and it can really speed up the process of banning ag chemicals.
Yeah. So, but do you see any merit in any arguments against?
Not really, because I think CRISPR is pretty much the same as traditional breeding, only you're helping a bit. It's not GMO, and yeah, I think it's just a new technology that you have to adapt, and that's what we've been doing in the Netherlands in breeding crops for 100 years, and that gave us a very leading position in the vegetable world. So yeah, I think we really need this to keep up and to keep a leading position in the food and vegetable industry in the Netherlands.
Yeah. So and Anja, I was thinking about your presentation that so formerly for organic agriculture the exemption could be used, but now is there any discussion in organic to accept those NGTs?
To accept NGTs.
Yeah.
No, the general view is that they don't want to use NGTs. They see it as a new GMO. So the IFOAM and other organic organizations, their standpoint is that they don't want to use it.
Yeah.
Of course, I can imagine that there are smaller organic farmers. Also, what like Johan says, it can, I think, potentially be used to lower the use of pesticides, and that's especially also important for organic farming. So I do see that there are potentials, but I think that at the moment it's not the group that we have to have on board. Yeah.
And what is your take on how the European Parliament actually voted like in favor, but it's still a very long road or not? Can you explain a little bit what like the timeline might be?
Yeah, so the European Parliament voted, and it also confirmed that vote before the elections. So they don't. In theory, it's possible to go back on that vote, but in practice it would be really quite difficult, and I don't think the European Parliament is going to do that. So it's really waiting on the Council to make a decision. And I think the discussions are not necessarily about the technique itself, but about other things in the European Union, such as patents or labeling.
Yeah.
But I think with the new presidency, so in January, Poland will be a president of the European Union. I think I hope also that there will be next steps made. So once the council, so they already have a majority in the countries that voted in favor, but they also need a majority in the number of European citizens, so more than 65%. I think with the new presidency, they might come to an agreement, and then once the council votes in favor, then all three institutions, so the Commission, Parliament, and Council, will sit together to see which amendments they want to see passed and which not.
Yeah, and it's interesting that you are like talking about one of the big arguments against is the patent issue. But I also remember talking to Johan that it's weird that because almost nobody is in favor of patents, not even like also farmers not.
Mm-hmm.
Johan, is it?
No, I think the current situation where we have the right that everybody can use each other's genetics is a very good system, and keeps progress in the breeding system, because everybody can use everybody's genetics. And I think all the breeders and the whole industry is pretty on track, that they want to keep it like that and do not want a patent. So yeah, in my opinion, especially in potatoes, it's a non-discussion.
It feels like a little bit weird. It's like a little bit of an artificial discussion. If everybody's against, sorry.
Yeah, I think it's a discussion that should be held outside of the NGT proposal, because I think it's a discussion that's a little bit broader. It's in general on patents in plants. And what Johan is saying, that plant variety rights should be enough. That's the general viewpoint of a lot of companies in the Netherlands. But then there's other companies saying that we need these patents because with these new techniques, the development will be a lot quicker. But it's a quite complicated discussion. But I think it should be really separated from the NGT proposal itself.
And Arif, I remember like the film we made together was also about the influence of Western thinking, or Western, maybe even like Western resistance against GMO on the farmers in Bangladesh. How do you feel about it now? Is it still a problem?
I think it's stronger now, the opposition and the blocking and the protest. And if I count it in number, I mean, we got our first biotech crop, genetically engineered BT eggplant, deregulated back in 2013, October 31st. It's been more than almost 10 years. And in last 10 years, we have not been able to move ahead significantly with the technology, with number of crop and the institutional capacity. Despite having institutional capacities, particularly with the NARS institutes, we have not been able to move ahead with additional crop or varieties. So the demand side from farmer field has always been very intense. I mean, when we went out in field with BT eggplant, they were saying that, okay, we need BT in other crop.
Yeah.
They don't know about the science and technology, but they want BT in every crop. You know, like they want to save the crop. That was their reaction. But we have not been able to move ahead. There has been pressure from the Western entities. Our friends and colleagues from Europe have been opposing biotech and GMO. And we have not been able to provide the age-old, like grandfather garden as a solution for these 180 million people to feed them 3 times, 4 times a day. So I'm still very much optimist, but it looks like that the clock is not ticking in everyone's wall. I mean, we are thinking it as an urgent issue, but probably it's not urgent for the decision maker. They don't feel urgency. The politicians have different, priorities and urgency, and all the pesticide companies, they have their own mandate and own strategy. So I would say that globally, the expectation was huge with these NGTs. The realities are quite different. I have been in touch with our colleagues in Africa, in Latin America. Latin America did well, fortunately, because they have made agriculture commercial to some extent. But if you see in India, if you see in Bangladesh or other smallholder farmer in Asia, you have small, tiny little plot, and with limited resource, they have to continue farming with whatever options they have. And we have not been able to provide them many options. Many options means we have not been able to provide them tremendous amount of organic farming technology. I mean, I'm in support of organic. If I can consume organic food 3 times a day, I like to buy organic food.
Yeah.
If I can have them in the same price, the same amount of money. We have not been able to provide them enough nutrient. More than 25% of our people, it's a study of FAO and other leading entities have been providing this data, that more than 25% people of Bangladesh are currently under threat of food security. So So these are like the vital issue, and we are talking about our next generation. These technologies are for next generation, and if we cannot provide enough nutritious food to our future generation, then I mean, you are not free from, because we are going to send hundreds and thousands of, like immigrants to Europe to
Yeah.
survive, So you have to make technologies available for all. That's like the core essence and
Yeah,
core
yeah,
message.
yeah. So, and Anja, like you are working on Wageningen, and they have come under scrutiny sometimes for like promoting a technique. Like there are some Dutch programs who say you shouldn't. That's not the role of a university. How do you see that? What do you see the role of Wageningen in, yeah, like promoting or at least giving information on these techniques and spreading it out?
Yeah, it's good that you're mentioning that, because I do have to say that I'm here as an individual researcher,
Yeah,
so
sure.
I'm not representing all of Wageningen University research, and there are different voices within Wageningen. I also know some other professors of mine. I do feel that there's a little bit more. There's a middle ground, because I do think that they're not against it per se, but I do want to see it adapted in the correct way. So not use it for herbicide tolerant plants and then go the same path down GMOs. So yeah, I'll keep the lights turned off. So I do understand the condition, the
Yeah.
concerns, and also if you have these resistant varieties with inserted R genes, you still have to monitor them in the field and see that those resistant genes are not immediately broken through again, because then it doesn't really help. There is a difference, because when I was at VIB, for example, they do have a clear standpoint that they are
Yeah.
in favor of NGTs. So it's different, but I think having a dialogue also with Arif said, there's still opposition against GMOs in Bangladesh. I have a question if that opposition is also against NGTs, or if there's a different scene. But I think if you look at the science at least, then and if you adapt a good policy in agriculture, then I don't think there should be a lot of opposition against it.
Do you know that, Arif, if there's any difference in how people in Bangladesh look at NGTs and genetic modification?
I have understood the question, and I was trying to frame the answer to the question. So I think the opposition would be same. I'm not certain that how they're going to react, because we have not applied for any NGTs yet. So unless or until we actually come forward with a particular crop or trait, then it's difficult to determine whether we are going to face similar opposition or not. But my assumption, based on my decade of work and knowing the people who are against it and knowing their power and connectivity and connection, I assume that they are going to be a strong opposition against NGTs.
And Johan, does Agrico, or do you like have a stance? Do you like lobby for a position, or do you see a role for Agrico or farmers in this discussion?
I think we would like to use the technology, but we also say it's not if the regulations are there and you can use it, that you solve everything within a few years.
Oh,
It's a tool and it's not a complete solution. And we also have to be realistic about it, because sometimes in the debate, it seems like that if you allow those techniques, that within 2 years all chemicals will be banned, and that's also not true. But I think it can speed up the process, and it can help breeding, but it's not like it's going to be solved in a few years.
No silver bullets.
And I also think that we want a level playing field. So if we stay very conservative in Europe, all breeding activities will be done in other parts of the world. And in the end, we all eat it. I mean, you see it with the GMO, the Roundup Ready soya and sugar beets from the United States. They're all in the market here. So in the end, we all eat it, while we cannot use it in research. And I think that's a bit hypocritical
Yeah.
to have a stand like that. And so, I mean, if the whole world is moving this direction, and we in Europe with 350 million people say we do not want to use it, we will live on an island in the end, and everybody else is doing the business and making the money, and we're still buying the goods and are not involved. So I think that's a risk that we are at in the current position in Europe.
Yeah, yeah, but also like for you personally, like if the rest of the world wants crisped potatoes, but you can't grow the seed of those, it's difficult for like the European farmers then.
Yeah, that's a threat. Yeah.
Before we go to the questions of the audience, there are not that many, but I'd like to address maybe the last question also for Arif. Like Arif works at WePlanet. What should we do as pro NBT people to make this work? What are your plans, Arif, to convince the world?
It's a very easy but very difficult question. I mean, what should not we do?
Yeah.
Because we have been doing a lot of things in last 10, 12, 15 years. And we will continue doing the same thing as a campaigner, as an activist. We need to continue sharing the evidence of science and the benefit of this technology to the community and to the farmer. We need to convince the politician that at the end of the day, politicians are for people. And these technologies are going to help for generations. And blocking the technology is not going to help anyone. So we have to convince the scientists not to lose hope, because I have seen many of the scientists working for 10, 15, 20 years and have not been able to get their product or varieties deregulated. It's very frustrating. They work days and nights under the sun, like in greenhouse, because I've been in close attachment with them for last few years and have seen that how tremendous amount of work they do. And the decisions are actually confined only to a handful of people. I mean, probably not more than 50 people in a country who are influencing the decision, who are getting paid by Greenpeace and other powerful entity, and they are determining what's good for people and what's good for farmer. This is not to be taken, not to be granted for all. I mean, we have to change the culture. We have to raise our voice. That's what we are planning to do, that we want to raise voice for science, for innovation, for truth, and for fact.
Yeah, thanks. And maybe, I'm not sure, do you have a position actually, Anja, on this? Do you also feel activistic, or do you?
I don't feel like I have to be activistic, because I often I do sometimes talk and give presentations on, but I'm mostly interested in people when I do notice that they're really against these techniques, why that is. And I do often see if I explain a little bit more, then they do understand or see different viewpoints. But I don't feel that I need to convince everyone.
No.
I think the biggest a good leverage would be if we actually have a gene-edited product on the market that is successful, both for producers, for farmers, but also for consumers.
Yeah.
And when I look at the products that are currently on the market, there are no disease-resistant products. So it's non-brown in apples, non-brown in potato, the GABA tomato in Japan.
Yeah.
There's quite a lot in the pipeline that's highly promising also for countries in Africa. But I think once we have something that is grown on a large scale, that is popular also with consumers, and it shows that it can lead to lower pesticide use, that would be the ideal example for NGTs.
Exactly. Yeah, that's also because we are talking a lot about those now Phytophthora resistance, but there are also research in potato to lower carcinogenicity, like when you bake them and stuff. So then there's more of a direct effect for consumers, and that might help acceptance.
Yeah, indeed. Yeah.
I was thinking that there are not that many questions. I thought it was quite some special, very specific questions on genetics. What I was maybe a little bit related to that, if you have the old potatoes in South America, are they resistant?
Is that a question for Johan or
Yeah,
for
it's
me?
for you, Anja.
Oh, for me, yeah. So there are really old potato varieties in South America. That's what they usually do. They go back to these old
Yeah.
varieties to find these resistant genes, but they're mostly not edible. So that's what Johan was talking about. If you want to breed into use breeding to get those genes into commercial varieties, it will take a long time. And originally these potatoes were also highly toxic, so you had to bury them in the soil for some months to be able to eat them. Yeah,
Yeah.
but that's what also is also being done for other crops. You just have to go back to the original gene pool to see if you can recover these
So
genes.
by
resistance.
accident breeded them out.
Yeah, or you never selected them in the beginning.
No. I see there's a question for Johan. Like somebody's asking, is conventional breeding of varieties with a single resistant gene not dangerous? By giving the pathogen time to overcome single resistance, we are perhaps undermining the future success of triple resistance varieties.
That's a quite technical question for
Yeah.
me, but we see that the single resistance varieties, especially this year, didn't keep up in the field, and yeah, there's a bit an argue about it, or if you lose a gen 1 year, or it's lost forever, or it will be resistant the next year again. But that's probably more a question for Anja to answer. But I think we have to start somewhere, and the first gen was a start, and now we're going to the second. And I mean, you have to get some common practice and some experience in how to use those varieties, how to monitor them, how to use them in combination with chemicals, but with less chemicals. So you only spray when you find an infection instead of preventive. And I think that we're trying to develop a system to reduce chemicals with those varieties. And I think, yeah, in an ideal situation, that's a phase that we're in now. And in the future, we have the 3-stage varieties, and then we don't have to use any chemicals anymore. But yeah.
Can you chip in, Anja, on this?
Yeah, no, it's true. Actually, it's a good question, and indeed, in the beginning, it was thought, oh, we have one resistant genes, it will be enough, but it quickly proved that it wasn't enough, seeing how fast the pathogen evolved. So indeed, if now there's a new resistant gene found, then at least breeders or scientists are quite unwilling to only put that one resistant gene immediately in the field without monitoring or without a combination of other resistant genes, because you do have the chance that you will get that resistant genes broken, and then in the future it won't be effective anymore. So if you're looking at the use of gene editing of NGTs, then you have to look at 3 resistant genes or more, or in different combinations, and then also monitoring the pathogens in the field.
Yeah. I saw already also a question very early on, and it might be for all of them, about the influence of climate change on on Phytophthora. Maybe start off with Arif. Do you notice already different weather patterns and also like different pathogen pressure?
Absolutely. Even the last year we have seen that the Phytophthora infestation was huge because of the climatic condition. Too much of fog, and we haven't seen sun for more than 3 and 4 days, which was very favorable for the lead blight infestation.
Yeah.
So potato as a cash crop for the smallholder farmer requires a lot of investment. You need huge amount of seed. Potato itself is a seed, and land, and preparation of the land, fertilizer, all the input they spend on. They think that they might make money out of it, but this unforeseen climatic condition, you can predict, but you cannot predict whether you will have infestation or not.
No.
And there is no natural resistance to it, even after spraying fungicide. Last year I was in the northern part of the country. I have traveled number of districts, Rangpur, Bogura, the potato intense region. I've been there, and each and every farmer, they were just taking precaution, and they were aggressively spraying fungicide.
Yeah.
Just because they found that few field, because it took only few days to get their field infested with the infestation. So I think climate change is actually threatening, um, and not only potato but other crops too. I mean, in next couple of years, or in next 10 and 15 years, we might get high temperature during night, which is not favorable for paddy production. Like if you have high
Oh, yeah.
temperature, you won't get much paddy, and we rely on eating rice. So I think, and this is only not only like the abiotic condition. Many part of the country, particularly the southern belt of Bangladesh, we see huge amount of soil salinity. So these are the conditions we are facing every now and then. And
Yeah.
it seems that every year we are getting a value addition to climate impact.
Yeah.
Instead of reducing them, something new is coming up. So we really don't know what's going to happen in next 50 years unless or until we start taking preparation now and start dealing with that. And there was a question I can see. um uh, One asked that whether we are thinking of other varieties. Definitely, we are thinking of other varieties. If you look into the history of lead blight resistant potato in Bangladesh, the research started with one gene variety first. I mean, one gene trait, and diamond and cardinal are the like most popular varieties of potato in Bangladesh. It's been grown for last 15-20 years now, and farmers are preferring other varieties. So this is a challenge for biotech and GMO. I mean, you start with one variety, by the time you get it deregulated, then for the farmer you have a new variety, because farmers don't continue a variety for more than 25 years per se. But generally, a biotech crop takes 15-20 years. So this is a dilemma, this is a paradox we are going to deal with in future too. So we have already identified few additional variety for Bangladesh, and we are working.
Yeah. And Johan, like, do you also see different weather patterns? Yeah, this year was like particularly bad, but there was also maybe El Nino. Do you feel the burden of climate change?
Yeah, I think we see a longer periods of the same weather, at least in my experience. So it's dry for a longer period, or it's wet for a longer period. And yeah, if you have a long wet period during your growing season, then late blight has a lot of moisture, and then it develops really quickly. And combined with higher temperatures, yeah, then you have higher pressure. I recognize what Arif is saying.
Yeah, so and there's a question from Thijs. I see the issue with Phytophthora that it's adaptable and there are many different strains. So what are your thoughts on this concerning NGTs? So you need, like, the question might be, you need to continuously, it's really hard even with NDBTs to defeat this. Or not, Tanya?
Yeah.
You need strong varieties.
Yeah, but with new technologies, you're probably quicker in adapting and making the changes again. So I think it's a continuous battle, but it will really help.
Yeah, yeah, and indeed, yeah, you can introduce these different genes into different commercial varieties and different combinations, and then with monitoring, it should last longer, I hope.
Yeah. I'm also asking Rob and Maria, who are watching together with me. Did I miss any questions?
There was one question on how to find R genes in old varieties.
How do you find those resistant genes?
Yeah, I'm not an expert myself. I'm not into finding R genes, but I'm in the group of plant breeding, and usually it's through QTL mapping. So that they do have genomes, or not the reference genome of potato is from a diploid potato, but they do have a lot of genetic material from old potato varieties for these reasons. They have whole gene banks. Also, Wageningen has a large collection of all the potato varieties. So through QTL mapping, you can find these new R genes. And there's I think a recent paper on the new R gene that has been identified. So Peru was published in Science, I think, from the plant breeding group. So it is possible.
Yeah.
Not
so
easy,
there's
but it is
still new
possible.
resistant genes to be found.
Yeah.
Yeah, might be a lot. Maybe as Arif, how do you see Arif, there's another question for you. How do you see the role of development aid on the agricultural sector in Bangladesh? And the preference of donor countries in adapting?
I mean, I'm not fully supportive about a lot of development aid because agriculture is very much traditional and it has to be grown within the country's system. We definitely need to get support, like the technical support. But if you continue getting technical support and financial support, there is like lack of commitment from or within the country to build the capacity. For example, in case of biotech and GMO, we have been getting from support from our colleagues from North American partner like US and other institute. And apart from academic, like knowledge, our own technical capacity has not been improved significantly, particularly both in the National Agricultural Research System and also not in the private sector. But we definitely require international support. I mean, who does not want international support?
Yeah.
But any support comes with some value addition and also some challenge. I'm fully supportive about getting support, but there has to be some like some understanding, and the bargaining capacity has to be within the national partner.
Yeah.
Most often, when we have international support, it seems that our international partners are telling us what to do and what not to. As an activist, I don't support it any longer. I mean, I want to understand what is right for me and what is not right for me.
So
I'm not
I
sure
think
whether
we
I
went,
could like make you happy with the answer.
I think we went through all the questions. I think I have the last question for Johan. Johan, how do you see potato farming in the future in the Netherlands or in Europe? Let's keep it.
I think we have a lot of challenges in agriculture, and we always find solutions. And I really believe that technology will help us finding those solutions. And there's still great demand for food and potatoes, and especially for seed potatoes as well. The market is really developing. I see lots of opportunities, and
That's nice.
blight is something that we have to deal with, and that we have to find solutions for. But I'm pretty confident that
Yeah,
we'll
nice.
figure it out.
It's
And,
not the end of potato farming.
no, not at all.
No. Thanks. I'll leave you. You can go back to the field, I think, in a minute. Back to the
Yeah,
cellular. Thanks everybody for watching. I thought it was really inspiring, and I hope you thought so too. Thank you.
Thanks,
Thank
Eden.
Thank
Rob
you,
Heston.
everyone.
Bye.
Thank you,
Thank
everyone.
you.
And hi from Bangladesh. Take care. Bye.
Yeah,